Q1. How would you approach exploratory testing in a situation where you have minimal documentation and the functionality is highly complex? In a situation with minimal documentation and highly complex functionality, I would take an exploratory approach by first gaining a basic understanding of the application through initial exploration. I'd then focus on high-risk areas, using my domain knowledge and experience to identify potential vulnerabilities. I would set clear testing objectives for each session, document findings continuously, and regularly collaborate with the development team to validate assumptions. Throughout, I would use techniques like session-based testing and leverage tools where appropriate to explore the application in depth while building living documentation as I go. Q2. How does Java handle memory management internally? Can you explain how garbage collection works and how you can fine-tune it for performance? Java handles memory management using a combination of automatic garbage collection and heap management. The Java Virtual Machine (JVM) divides memory into the heap for object storage and the stack for method calls. Garbage collection (GC) automatically reclaims memory by identifying and removing unused objects. It uses algorithms like generational GC, which divides objects into young and old generations, collecting younger objects more frequently. Q3. How would you implement multiple inheritance in Java, given that Java does not support it directly? What are the potential challenges when using interfaces for this? In Java, multiple inheritance is not directly supported with classes due to potential issues like the diamond problem. However, Java allows multiple inheritance through interfaces. An interface in Java can be implemented by multiple classes, enabling a form of multiple inheritance. Method conflicts. If multiple interfaces have methods with the same signature but different default implementations, the implementing class must provide an implementation to resolve conflicts. Complexity in design. Overusing interfaces for multiple inheritance can lead to complex and harder to maintain code structures. Q4. What is the difference between concurrent hash map and hash map? In what scenarios would you use one over the other in a multi-threaded environment? Concurrent hash map and hash map are both implementations of the map interface in Java, but they are designed for different use cases, particularly in multi-threaded environments. Hash map is not thread-safe. When multiple threads access a hash map concurrently and at least one of the threads modifies the map structurally, it must be synchronized externally. Without synchronization, you risk data inconsistency or exceptions. Concurrent hash map, on the other hand, is designed for concurrent access. It allows multiple threads to read and write to the map without the need for external synchronization. This is achieved through internal synchronization and concurrent design, which reduces contention and improves performance in multi-threaded scenarios. Q5. Can you explain the difference between driver.findElement and driver.findElements? How would you handle cases where elements are dynamically loaded on the page? Driver.findElement by locator. This method returns a single web element that matches the specified locator. If no element is found, it throws a no such element exception. For example, web element search box equals driver.findElement by .itSearch, search box.send key Selenium. Driver.findElements by locator. This method returns a list of web element objects. It returns an empty list if no elements match the locator, rather than throwing an exception. This is useful when you expect multiple elements. Handling dynamically loaded elements. For elements that are dynamically loaded, you can use explicit waits to handle timing issues. WebDriver wait allows you to wait until a condition is met before proceeding. For example, WebDriver wait equals new WebDriver wait driver 10. Web elements dynamic element equals wait dot until expected conditions dot visibility of element located by dotted dynamic element dot click Q6. How would you handle synchronization issues with Selenium WebDriver in cases where JavaScript heavy applications cause inconsistent element behavior? To handle synchronization issues with Selenium WebDriver in JavaScript heavy applications, where elements may behave inconsistently due to dynamic content or delays, follow these steps. Use explicit waits. Leverage WebDriver's WebDriver wait with expected conditions to wait for specific conditions before interacting with elements. For example, wait until an element is visible or clickable. Handle JavaScript delays. For elements affected by JavaScript execution, wait for the JavaScript to complete by checking specific conditions or using JavaScript executor to verify the application state. For example, use Fluent Wait. For more complex scenarios, Fluent Wait allows you to customize the wait conditions and polling intervals. Q7. How would you handle test dependencies in TestNG? Can you explain how depends on methods works and how to ensure that test cases are executed in a specific order? In TestNG, handling test dependencies and ensuring specific execution order can be managed using the depends on methods attribute. This feature is used to define the order in which test methods should be executed based on their dependencies. How depends on methods works definition. The depends on methods attribute specifies that a test method should only run after one or more specified methods have been successfully executed. Example, if you have a test method test login that needs to be executed before test purchase, you can set up depends on methods like this. Q8. What are cucumber hooks, and how would you use them to manage database states or perform setup/cleanup tasks around specific scenarios? Cucumber hooks are special methods that allow you to run code before or after each scenario or feature. They are useful for managing setup, teardown, and shared state across tests. Types of hooks: add before, executes code before each scenario. At after, executes code after each scenario. At before step, executes code before each step in a scenario. At after step, executes code after each step in a scenario. Imagine you are testing an application that interacts with a database. You might use hooks to ensure that the database is in a known state before tests run and is cleaned up afterward. Here, the at before hook ensures the database is reset before each scenario, while the at after hook cleans up afterward. This setup helps maintain test reliability and isolation by controlling the state of the database. Q9. Can you explain how you would implement a modular, maintainable automation framework using Selenium, TestNG, and Maven? How do you ensure scalability? Framework structure. Core module includes WebDriver setup, configuration, and utilities. Page object model, POM. Each page has its own class for locators and actions. Separating page code from test logic. Test cases module contains TestNG classes that use POM classes for test execution. Data module manages test data and supports data-driven testing with sources like Excel or CSV. Maven configuration dependencies. Use the pom.xml file to manage dependencies like Selenium, TestNG, and any other libraries. Build lifecycle. Define phases for test execution and reporting. Configure Maven Surefire plugin for running tests and generating reports. TestNG configuration test suites. Define test suites in XML files to manage test execution order and grouping. Data-driven testing. Use TestNG's as data provider annotation for running tests with multiple sets of data. Scalability and maintainability. Reusable components. Use utility and POM classes for common functionality. Dynamic configuration. Manage settings with configuration files for easy updates. Parallel execution. Configure TestNG for parallel test runs to enhance speed and scalability. For example, in a login test scenario, page object class, create a login page class with methods for entering username and password. Test class. Create a login test class that uses login page to perform login actions and verify success. Configuration. Use Maven for dependencies and build processes. TestNG XML for test suite management. External property files for environment configuration. Q10. How do you handle test automation in an agile environment where requirements and features are continuously evolving? How do you maintain the automation suite? Modular framework. I build a modular and scalable automation framework. For instance, using Page Object Model (POM) in Selenium helps separate test logic from UI elements, making it easier to adapt to changes in the application's UI. Prioritize test automation. Focus on automating critical and frequently tested features. For example, if the login functionality is integral to multiple workflows, I prioritize automating it to ensure it remains reliable as features evolve. Continuous integration. C. Integrate automation tests with C/CD pipelines. This ensures that tests run automatically with each code change, providing immediate feedback and allowing quick identification of issues. For instance, using Jenkins or GitLab CI, I can automate test execution after every commit. Regular updates. Continuously update the automation suite to reflect changes in application functionality. For example, if a new feature is added, I'd adjust or add test cases accordingly, ensuring coverage remains relevant. Collaborate with the team. Maintain communication with developers and product owners to understand upcoming changes and adjust the automation strategy as needed. This helps in preemptively addressing areas likely to be impacted by changes.